Good morning, enjoy the student. Today we start photoelectric effect. So for photoelectric effect, photo means your light and electric means electron. Electric effect we are doing photoelectric effect. In this, what happens? We have to take your alkali metals here. Now your alkali metals we have in outermost shell we have electron, and another thing about alkali metals that the electrons in the outermost shell is far away from the nucleus, so it is easy to take out the outermost electron from an alkali metals. So we have chosen alkali metals. Now here in the alkali metals, when light falls on the alkali metals, if the energy of light, this energy is h nu of light, is greater than the energy of attraction of the electron and nucleus, this energy is called E naught for a substance. This is equal to h nu. The energy that we are striking a metal surface is greater than E naught, which is equal to h nu. Then electrons are coming out from this metal surface and runs via this wire, and if you have an emitter, you will get the deflection in the emitter. This type of phenomenon is called your photoelectric effect. The definition is the phenomenon of ejection of electron when light of certain frequency falls on a metal surface is called photoelectric effect. So this ejection of electron from the metal surface and light from certain frequency, the light that falls, it must have more frequency, nu must be greater than nu naught. Now the question arises, the energy with which strike that metal surface must be greater than E naught. Now by the law of conservation of energy can neither be created nor be destroyed, but it can transfer from one form to another. So that become E minus E naught is also a type of energy, and this energy is the kinetic energy, and this kinetic energy is half me into v square for electron. Clear? So the extra energy with which we are striking, that one is utilized as kinetic energy, which implies h nu for this one, then h nu naught equal to half me into v square. So the formula becomes h nu equal to h nu naught plus half me into v square. This part is also called E naught, and which is also known as work function. So that point you require to be remembered. Now results of photoelectric effect. Now 1 point student, the electron were ejected from the metal surfaces as soon as the beam of light strikes the surface. So there will be no delay. When the light strikes the metal surface, at that time electrons come out. The number of electrons ejected is proportional to the intensity or brightness of light. Means how many electrons will come out, that depends on the intensity or brightness of light. The more number of light you strike the metal surface, light with 3, then 3 electrons will come. For each metal there is a characteristic minimum frequency nu naught, which is called threshold frequency. The threshold frequency is characteristic minimum frequency below which photoelectric effect is not observed, below which we are not going to photoelectric effect. So there should have a characteristic minimum frequency. For example student, if you take potassium Potassium has characteristic minimum frequency 5.0 into 10 to the power 14 Hertz. Now, if I struck with a light of red light, which is frequency 4.9 into 10 to the power 14 Hertz, so there will be no ejection. There will be no ejection. Now, instead of one light, if struck with the two light, then also no ejection. If struck with three light. Now, instead of red light, if you add yellow light, which is frequency 5.1, then with one you are striking, you are getting one electron. With two you are striking, two electron, three electron. Means what? This frequency, this is your frequency. So whether the electron will eject, that depends on frequency, and number of electron eject, that depends on intensity. How is possible that? Now, if I one yellow light with 5.1 10 to the 14 Hertz, the electron ejection will start. So that depends on frequency of yellow light 5.1 10 to the 14 Hertz. Now, instead of one, if you are adding two, then two electrons come. So number of yellow light, number of electron come. That is your intensity. But whether the electron come out, that is depends on the frequency of that. So these points you remember. So finally today we are solving one problem. Find the threshold frequency nu naught. The threshold frequency nu naught for a metal is this. So we have nu naught 7 into 10 to the power 14 Hertz. Calculate the kinetic energy. You have to calculate kinetic energy of an electron emitted when the radiation of frequency nu equal to 1.0 into 10 to the power 15 Hertz strikes the metal surface. We have to find out from this. So we have student formula for kinetic energy is equal to h nu minus h nu. We take out the h common, nu minus nu. Value of h, Planck's constant we have learned. We are doing here, value of h is your 6.626 10 to the power 34. Nu is given 1.0 10 to the power 15 minus 7 into 10 to the power 14. So which implies 6.6 10 to the power minus 34. This is the value of h, and here you can write 10 into 10 to the power 14 minus 7 into 10 to the power 14, which implies 6.626 10 to the power minus 14 equal to this into 10 to the power 14 10 minus 7, 6.626 10 to the power minus 34 plus 15 into 3. You just multiply with this one, you will get the result. So student, up to this today, you try to solve all these things. Thank you.